Hi everybody. In this video, I'll show you a small gas-fired furnace that I've built with relatively cheap and easy to find materials. Warning: operating a gas furnace and handling molten metals can be extremely dangerous and might result in a serious injury or even death. Besides the obvious fire risk, a gas furnace should only be operated in a well-ventilated room or outside to avoid exposure to high levels of carbon monoxide and other harmful gases. Let's start with the furnace's outer shell. As you can see, it's made of a simple steel pail cut about a third from the top. The burner hole is cut on the wall of the bottom stationary part of the furnace, and another hole is cut at the middle of the furnace cover. Both parts of the furnace are fully lined, top to bottom, with 2 inches of ceramic fiber insulation blanket. On the bottom, there is an insulation brick to provide a stable footing for the crucible. All of the insulation is rated for a working temperature of 2300 degrees Fahrenheit. A roll of 1-inch thick insulation blanket, 2 feet wide and 23 feet long, cost me about $60, and I only used about 3 or 4 feet of it for this project. Now, let's go over the burner setup. I've placed a regular torch on top of a small DC servo blower. The valve on the torch is used to regulate the gas flow. The blower speed is regulated by a laboratory power supply. The final piece is the burner itself. It is basically a 1/2-inch plumbing pipe fitted with a 1-inch to 1/2-inch reducer that acts as a flare. There are basically 3 types of flames possible: reducing flame, neutral flame, and oxidizing flame. Without drifting too much into the subject, each type represents the gas to oxygen ratio flowing through the burner at any given time. A reducing flame is such when there's more gas than the available oxygen could burn. It produces lower temperatures and is usually recognized by a hissing sound. An oxidizing flame is exactly the opposite, burning very hot, and it produces a roaring sound. A neutral flame is when the ratio is just right, meaning there's exactly the right amount of oxygen available to burn a given amount of gas. It is also called the stoichiometric point. Here's the crucible I'll be using for this melt. To produce shot, I've drilled a few holes into the wall of the crucible so I could easily pour the molten metal into a bucket of water. And here's what I'll be melting today. There's about 8 pounds of pure silver in there. This silver came from an electrolytic refining process, and in case you were wondering, it is 99.99% pure. The crucible is placed in the furnace, right in the middle. And the furnace is lit up. It is important to start the furnace with the lowest setting possible in case there's some leftover moisture in the melt or the crucible material itself. Ceramic crucibles can also suffer thermal shock and crack if heated too fast, even if it's completely dry. I'll put the cover back on and let it do its thing. Here we are about 5 minutes later. Everything is red hot, as it should be. About 13 minutes into the melting process, all of the metal is molten and ready to be poured. Hold on. If you thought that was cool, check out this next footage. Here's the final product. This is of course not a perfect design, so if you have your own furnace, take a video or some pictures of it and post it here in the comments section below. That's it, folks. Hope you've enjoyed this short demonstration. Please comment, share, and subscribe.